Today's conversation is with Sam Pickles, founder of RedShield, a web application firewall company. We discuss the history of WAFs, how things are evolving from a threat landscape, and how to operationalize security for enterprises that have hundreds or maybe even thousands of websites to fix. We also discuss some issues about how WAFs are deployed, how competitive models don't appear to work, the massive skills shortage, and the realities of fixing legacy code. With that, please enjoy my conversation with Sam Pickles. Hello and welcome to the RSnake Show. Today I have Sam Pickles. How are you?
I'm very well, thanks, Robert. Great to be here.
And you flew in from...
I've come in from New Zealand via Boston, Virginia Beach. I spent a little time in the Appalachians this weekend. It was great. So I've been all over.
Hanging out with the hillbillies out there.
Exactly, yeah. Getting my redneck on. I got my pickup truck. I headed for the hills. It's great.
That's beautiful country.
It's magnificent up there.
It's amazing. It's one of the few places I think I could just get a cabin somewhere and just disappear.
Oh, yeah. Yeah, especially if the bears get you.
That's right. Different kind of problem. So, yeah, roadshow. Is this a sales thing or?
Yeah, visiting customers and partners and running projects and meeting with staff and just all the usual things.
Wow.
Yeah.
Yeah, okay. World tour.
Yep, all of that.
I feel like a lot of startup founders, that's pretty much your life. You just
it is
meeting rooms, hotel rooms, airports, cabs.
That's right,
or Ubers, and that's it.
You go to these fantastic destinations like Austin, Texas, and I see taxis, hotels, airports, and it could be anywhere.
And sometimes a studio.
Well, sometimes a studio. This is a lovely studio. This is a special treat. Yeah, so that's great. But years ago we lived in Boulder, Colorado. A few years ago as a family, and our plan was to move back to New Zealand, and I'd come back to the US regularly and continue to work here. And then that was 2019, and then things changed a little, and there were no flights, and the world shut down with COVID. So it's actually been a few years since I've been back here. So I've got kind of a backlog of people to come and see. So
well, welcome back.
Yeah, it's been great. Yeah.
All right, so why don't we tell the audience a little bit about how you got started in information security? I think that might be kind of compelling.
Oh, absolutely. So, way back. Sadly, I've really only ever worked in security. It's been a passion of mine for a long time, but originally I majored in physics, and I wasn't going to be a scientist. I ended up working for a company that does security for bank vaults and ATM machines, actually physical security, cash handling. And I found that really interesting. And everything started to become networked and electronic, and so very soon I started moving into IT security and went and did some computer science and kind of retrained myself across. So that was 25 odd years ago now, and I've been in cybersecurity and haven't been able to drag myself away from it ever since.
What do you like about it?
I like well, it's the only part of IT that they make movies about. I mean, there's, they're not making movies about storage. We're running out of hard drive space. And I don't know, just you've got criminals, you've got nation state adversaries. There's a lot at stake. It can go really wrong really quickly. There's, it's exciting. It's really complex. I love the intellectual side to it. If you work hard and if you study hard, then you can pretty much guarantee you're going to be okay. So it's been a great field, I think.
Well, if you want to get into a field where they write movies, how about video games? There you go.
Yeah, could be.
You're not going to make any money doing that, though.
Pretty sure I have to stay in my lane at this point. Yeah.
That's too many years.
Yeah.
Okay, so you started this little company called RedShield.
Correct, yeah.
So tell me about that.
Yeah, so that was around 10 years ago. So I was working for a large security infrastructure provider, and we were making this really smart technology called web application firewalls. And I can say it's F5 Networks. It's a great company. I love F5. I did find that technology, as powerful as it is, that many of our customers would have difficulty using it to its full capacity.
Oh, absolutely.
And my job really at F5 was to try to convince the large systems integrators, telcos, and this is before we were talking about cloud providers, going back around probably 17 years ago now when I started with them. I was really trying to get our partners to build a managed service offering that would really kind of allow this technology to stretch its legs. And it has huge potential to solve some really difficult and very relevant security problems, but it's kind of out of the reach of customer teams to achieve that. And so I really was trying to get managed security service providers to build a specialized service around this.
So before we go down that path, what is a web application firewall?
So a network firewall, by contrast, looks at systems talking to systems, and it says people over here are allowed to talk to people over there. You can't tell what they're talking about, but it'll say yes or no based on where you come from and where you're going. A web application firewall actually looks very deeply and says, okay, you two can talk to each other, but you're not allowed to access the admin part, or I've seen you try too many bad passwords, or I just saw you do something that looks like you're trying to hack the application and you're going to get blocked. So it's a much, much smarter and deeper inspection of the actual conversation between systems.
And so why is that difficult? Like why can't I just throw an F5 in my network and call it a day? And why wouldn't it just automatically fix my problems?
At a basic level, you can put it in there and it'll work. It won't break stuff. But then quickly you start to get into pretty complex area. Reality is applications are pretty complex, and developers know this. Penetration testers know this. As soon as you start really looking under the covers, they can become devilishly complex. And actually, the security problems that accompany that are really just as complex as the apps themselves. So it's hard if you're not a specialist. You may not be a specialist in web apps, you may not be a specialist in security, and you may not be a specialist in the platform itself. And you really need to join all three of those things together to get everything really switched on and cranking, so that you've got the absolute best chance of seeing something bad happening that you want to stop and successfully stopping it, but not breaking anything in the process. Mm-hmm. It's not an easy, it's a difficult balancing act. It really is.
So what got you down the path of wanting to turn this into a service offering?
Well, I realized that there was a set of elements that you needed to make sure that your project would succeed as a program over the long term. You really need penetration testers. You need security researchers who are able to talk to you about the problems that you have in your apps, and really specifically to your apps, because every organization is quite different to each other. You also need to have the platform specialists that know how to deploy the tech and how to run it. And then you need operations people who know how to respond to things over time. And you also have to respond to, there's a problem called false positives. So a false positive is where a user, let's say you go to apply for a mortgage and you're typing your name into the form, and then suddenly you get blocked, and it's, what's going on? It's not fair.
My name is null.
Right, exactly. my name just happens to be null. Okay, so you get blocked. Now, a business, when that happens, and it does happen, the business will very quickly say, well, just switch that thing off, get it out of my network, and it's not going back in there again until you can guarantee that will never happen again. And you can't make that guarantee. So that's therein lies one of the major issues with this kind of tech. So we realized actually that it is absolutely critical that firstly you tune it properly so that doesn't happen. And if it does, you respond to it really quickly, within minutes. So somebody says, hey, I'm trying to apply for a mortgage here, and they get blocked, then you have to give them an invitation to request support, and then you've got to turn it around within minutes. And that way, you earn the right to stay in the network. Otherwise, you get switched off. And these kinds of elements where you really need all of these things, and you need vulnerability scanners, and you need somebody to read the results of those, and you need developers to take it a little further, and we can talk about that when we talk about shielding. So with all of those elements, I thought, okay, honestly, I'm having difficulty getting managed service providers to put all of this together, so I'm going to go do it myself. And it started out that way. And I worked on this for a number of years.
I mean, why not just be a VAR at that point? Why not just do it for them and get them to do it?
You mean do it for the vendor on behalf of the vendor? Yeah. Well, my theory was that customers, they know about these big famous technology companies and they trust their technology, but reality is what they really want is just not to get owned through their web apps. You just don't want to get breached, and that's really the outcome that you want at the end of the day. And so it doesn't matter if it's a vendor A or a vendor B, whatever it is, as long as somebody switches it on, somebody runs it properly, it doesn't break anything, and it delivers at the end of the day that we don't get breached through our web apps, then that's success. So it wasn't just a case of, well, here I'm going to sell you something and get it working and then leave. It's actually, realistically, it's a program that never ends. You have to continue operating these things indefinitely. And security, like it or not, it's a program. It's not a project, much less a product. You really do have to continue it on. So it had to be a managed service, which is, and you know, for a lot of organizations as well, it wasn't practical to deploy a technology stack in every single environment. A lot of companies just wanted to have a share of a multi-tenant environment. So we put together a cloud offering that customers could just migrate their apps onto us, and it meant that we could deploy very quickly. So all of those requirements, I guess, led us down the path of building a cloud system, assembling all these different teams, and getting all these business processes developed. This took years, by the way, to get this right. When I first started, I thought I knew how to do it. I didn't know how to do it. Our first business model was really completely unworkable, honestly, which was we were going to write shields and we were going to release them to customers, and they'd install them in their own environment and would support them, and it was way too complex and it didn't work. So eventually we just said, okay, hey, let's make this really simple. You just have to move your application traffic onto our environment, which is an easy thing to do, and let us run the security piece for you, and we will give you the outcome that you won't get breached through your web apps. Let us worry about how to do that, because there's a lot of things you need to do to make sure that that is the outcome. And we'll report back to you, let you know how you're doing. And then at a higher level, you know, the board of directors wants to know how much are we spending, what are we getting for it, how do we compare with everybody else in the industry, and how's our program delivering.
And that's much easier to do if you're in the middle.
Yeah.
You can be looking at all of the customers at the same time and getting metrics across all of the industries.
Yes, yeah, and there's a couple of ways in which that goes really well. One is economy of scale, because I build an analyst team and we can share it for everybody. And the other is that we can actually share IP between different deployments. So again, we'll talk a little bit about what vulnerability shielding is, but once we've done a project for one set of websites, let's say, then all the things that we have to build and customize and do for that are then go into the library, and it makes it, over time, it gets more and more efficient to do this for new customers. So we reached the point where we do a project for a large organization. Let's say they want to run with 500 websites, let's say, as a deployment, as a project. We can do 95% of that now just straight out of the library without having to write any new code. And that is, because of this kind of accumulation of IP over time. So for that reason, the multi-tenant thing definitely works well for our customers.
So it might be worth talking a little bit about the history of web application firewalls, like kind of how we got here.
Yeah, absolutely.
Can you give me a little rundown?
Sure. Yeah, so my favorite one was probably developed in the late 90s. There's open source ones as well, and there's commercial ones. And this has been a market. You can go out and buy a web application firewall, and you've been able to do that since, I guess, early 2000s, something like that.
Sounds right.
Excuse me. There was a couple of vendors came out of Israel. A lot of wonderful security technology comes out of Israel, and the technology that we ended up using came that way, and it was acquired by F5, this American organization. And there's also the open source stuff as well, which was written by a very clever researcher called Ivan Ristic, who you probably know.
Sure do.
And so Ivan wrote a plugin for Apache, which was called Mod Security, and that was really successful. A lot of people used that. But I remember, Ivan and I would be at the OWASP meetings in London, and I'm the kind of the commercial guy, and he was the open source guy. But we would
staring each other down.
Well, no, the opposite. I feel like we were kind of, we were the ones in the center of the room where everybody was kind of throwing mud and going, these things suck. They're hard to run, and they slow my apps down, and all these kind of, I guess some of the objections that people would have.
They just love to hate it.
There's a lot of love to hate but the things that I still absolutely love about them is that you can solve these really, really gritty real world security challenges in a way that, I don't know, there aren't many security vendor products that can actually be used to do things like that. It's generally everything just falls on developers. You get past a certain point, it's okay. There's things you can solve, like let's say DDoS, for example, and network security and remote access. And there's things that you can solve in security using a vendor product, but so much of it just ends up on the devs. It's, a penetration tester comes in and says, oh, all your users have got weak passwords, and there's no product for that. Right, it goes on the devs. And so there may not even, if you think of a government department that has 700 web applications and, maybe only a couple dozen developers, they're never going to get to it. It's really, really difficult for them to kind of get across this problem. So, we've got 1.8, I think it's around 1.8 billion websites in the world, but we've only got 27 million developers. They're pretty busy. Yep. So it's hard for them, right? So I just love
and not just that they're busy, they also can't touch a lot of these apps. They're not allowed to, or they don't have access to them. Right. Or they're run by another company and they just happen to be routing some stuff through them. Yeah. I mean, it's so complicated.
Right. And development being what it is, it's not productive to continually switch your focus. You need to focus on something for at least hours, if not days at a time, to really produce meaningful output. And so if you want to go and fix something, you need to really put time into it. And you can't do too many of those at once. It's just it's the nature of software dev. So with those kinds of challenges, I think it's incredibly satisfying to have something, an alternative, something that you can put in front of the app and it can actually solve these challenges, which is really what the security kind of vendor product space has always set out to do. Mm-hmm. But I think WAFs are uniquely positioned in their ability to actually do that. I would say, though, that, yes, let's split as well the definition of a WAF. I tend to think of a WAF as being something that can see a bad thing and block it. So now there are some extended capabilities where you can create much more complex behavior that I think is going beyond the WAF sort of space. And we do, and I want to talk about that a little. But a WAF to me is something that sees somebody try a bad thing and blocks it. And that actually is a little limited as well.
See, I never thought of a WAF like that. I always thought of a WAF as being an injector and a listener at the same time. And okay. Because back in the old days, what I really thought is you should be able to inject HTTP headers, like inject things that would stop bad attacks from occurring, like better cookie policies, or, back in the old days, that was really one of the only things you could do, or minimum upgrade you from HTTP HPS, just automatically always route you up. Even if the application doesn't know anything about that, at least you can do it at the WAF level. So I always thought of it as minimum a slight improvement of capability, and at maximum you could do like application pooling behind it and all kinds of cool stuff, and really route the traffic depending on what's happening. And there's all kinds of neat things.
Okay, so I think
I realize I have a bit of a nuanced view on this.
I totally get it, and I know in practical terms, most of the WAFs you can buy would have those capabilities because they're also sitting on top of a proxy. Right. We used to call an ADC. I don't know if people still use that word. An application delivery controller, like a fancy load balancer. And they're programmable and they're full proxies, and they can decrypt the traffic and they can do all this cool stuff, which is not actually the WAF part of it. And so that gives it all of that really smart capability to inject headers and do those things that you were just talking about. I think, though, that the WAFs are viewed, I think, largely as a commodity thing. You have one or you don't. It's on or it's off. And that has been dumbed down a lot because a lot of them are actually deployed out of path. So it's kind of watching the network over there, and if it sees something bad, it like sends a reset packet and tries to stop the conversation. But it can't do...
Those are the worst.
Right. I think they are too. But a lot of, especially in the early days, network people would say, hey, you're not putting this thing in my network. It can sit off to the side. So that was all you had as a security guy. You're like, well, okay, I'll plug it in and it can just listen and do its best. It'll try and interject and stop stuff.
This is always a dumb argument because they're worried about blocking network traffic. You can still block network traffic with reset packets. Yeah. I mean, it doesn't work as well, but it still would take down any connections going in and out. So I never understood that logic.
Well, it depends on... I guess for each organization, the network guys have been around for a while. They're pretty senior. They've got all the budget. The security guy may or may not have had the influence to be able to, and the network guy also he's been through outages, and he's been through, an outage that gets to the CEO. Let's say your oil trading platform is down and it's a network problem. Yep. Well, I mean, that's scary. Somebody gets fired and the next guy gets promoted into his role, and next time around, he doesn't want anybody he doesn't want anything being put in the network. So I do get how people get ultra paranoid around change control and that kind of thing. But if you step back and look at it, well, the only reason we even have a network is because of applications need to use it. And you know, people need to access their data and perform some sort of business process. And then the only reason we have network security like firewalls is because the application has some sort of precious data in it that you want to look after. And then if you think, well, okay, the worst thing that can happen is that information gets stolen or corrupted in some kind of way, or in the shorter term that somehow that service gets interrupted. Mm-hmm. So that could be DDoS, but it could be something else as well. Yeah. For all those reasons, I think the risk of not having decent technology in path is greater. And I think most organizations are there. I'm sort of thinking, you know, the network guy and the whole WAF sitting off to the side thing is kind of 10 years ago, I think.
Well, thank heavens. That was always a bad idea. Let me spend a minute explaining why for the audience, because this may not be obvious. Let's say, like I'm throwing a ball to you and there's somebody in the middle who might catch it as opposed to standing directly in front of it. Well, that'd be a problem if they miss, a big problem. If you're directly in line, you're not going to miss, right? You're just going to get hit by the ball. It's definitely going to hit you. It's sort of like that. When I inject something bad, it has to go to you, but it also has to go off to the side to this machine, which might take time to decide whether it's safe or not. Meanwhile, you're actually already doing things with the thing I just sent you. You're already
too late
running. It's already too late, depending on the payload. There's some that it can block. But I would say at least a third of the attacks that I would normally do could easily bypass that design. And that's a lot. And those particular attacks tend to be very bad attacks too.
Yeah, they do.
So not great ones to miss. And so it's interesting that you think that that's going away, and I'm really glad to hear that.
I do.
And so why do you think that's going away?
Why is it going away?
Yeah, why is that happening?
The cool thing is, I think actually, somewhat unexpectedly, I actually think this is being driven by developers and by public cloud, where you now have developers who are independently, maybe with so software programmers and partnering with DevOps people, or you know, maybe a dev team that can do both of those things. Mm-hmm. So you're able to write the code and you're also able to deploy it. And the cloud providers, like you know, the Amazons, the Microsofts, the Googles, and the other large cloud providers are doing a really good job of providing the tools to developer teams so that they can now independently deploy their own infrastructure. They no longer care about networks and routers and firewalls and switches and all those other things that you have to do. It's abstracted away from you. And what we're getting with that now is these design patterns. Here's how you build an app, and it's got this application proxy out the front that does the load balancing, and this is just how you do it. You just declare it and make it so. And now if we just want to add security to that, well, you just declare that too. And the cloud providers are the ones who are steering that tool set towards the better practice, which is everything's in path. Mm-hmm. And it's having a really nice effect on security infrastructure because developers building these systems, they don't have to stop and go and have a security design done where the security team has to go off and engage with the network team and all the different vendors and plug all this stuff together. It's just so much more efficient. But over time, the security controls are getting better and better, and by default, everything's in path. Mm. And I think that's a really nice effect.
Out of curiosity, are you thinking about possibly trying to put things in line within their infrastructure as well?
Yes. Mm-hmm. Yeah, because you've got, if you think of, there's a type of network called a CDN, or a content delivery network. So if you're running, these kind of started, I guess, in the 2000s, maybe earlier. That's when I kind of knew about them. Where let's say you're running a major newspaper, or you've got a lot of content to put out to the world, and you need somebody to be able to access it in Bangalore or in London or in Australia, and it needs to load quickly in the browser. And so what these networks would do would be to take your news story or your video, and they'd kind of distribute it everywhere around the world. Now that sort of architecture, originally it was very expensive, and it's still possible to do it in a very expensive way. But it's also becoming quite commoditized. And with those sorts of tools, we're putting now, and then you layer security on top of that, and especially for denial of service. It's a very natural architecture for responding to denial of service, is having this kind of really big distributed edge. So I think it's been the CDN architecture has kind of really won out as being at a network level how you should build things. And so then, having Azure and AWS just giving you that in a way that you can just kind of switch it on and deploy it is really driving some awesome improvements. There's still some pretty serious limitations though to, when you build a network like that, but then let's say you are migrating legacy applications into the cloud environment and you've got a whole lot of users that have created an account and reused a weak password, let's say. Something like a CDN or a WAF can't really help you with that. And this is where what you were talking about before, saying my view of a WAF is that you can interact with the traffic and you can inject things and do things. That to me is getting beyond what a WAF does. What I'm talking about there is things like, okay, I see a user logging in and they've got a weak password, and I know that exists in the dark web in a big database of stolen passwords. And the problem now is that a hacker could take that database and try all those passwords and successfully compromise the account. So it's quite a serious issue. And in fact, we should talk about this a little more, because This is how the greatest number of breaches, honestly, right now is actually happening this way. So if I'm sitting in front of an app and a user's coming in and they log in and I see they're trying to register with a weak password, then I can't just block that. It's not very helpful. I need to give them a message that says, hey, you need a stronger password and here's what you need to do. Or if someone logs in, I need to redirect them to the change password page. And this is all quite interactive with the app. It's much more than just injecting a header or just seeing something bad and blocking it. And so these kinds of, this is where we get into what we call shielding. And this is where what we're actually doing in the network out in front of the app is much more complex than just block a bad thing. Mm-hmm. You have to really kind of work with the application to solve the problem.
So before we get there though, what is the current threat landscape? I mean, what are these apps facing today? Like, could you just give us like a kind of rundown?
Well, yeah, sure. In fact, I can tell you actually literally from today. So, so a few hours ago, I was working on this with one of our customers was getting challenged. So what I've noticed is that a lot of attacks require a very large number of requests. They are so a web application request, an HTTP request. It requires a lot of those to work, to succeed. And if an attacker does that, then it's quite noisy, and the security team can see it, and a security device might detect it and block it based on some sort of threshold. So what we're seeing happen instead is that attacks are becoming split. And so one IP address will pop up on the internet and it'll fire a couple of requests at you and then disappear. And then another one comes up and continues and then disappears, and then another one and another one. And between them all, they'll conduct the attack, but no one of them is going to hit you too many times. They like to stay low and stealthy. And so we were watching this happening today from a whole lot of IP addresses. There's a couple of, I think, nation states which are behaving in this way, and it is, to me, it's more of a nation state thing maybe than organized crime, although there are some nation states for which those lines are very blurred. But if you think about one nation in particular where most of the hacking activity is in some way quite directly related to the government, you've got these big networks, and address 1, address 2, address 3, address 4 is all going to have a go at you. Somebody's running a pretty big operation there. Yep. They've built enterprise grade infrastructure, and that's a team of people who've been working for a long time. All of that stuff just says nation state to me. And so that's how these attacks are occurring. And it could be that, maybe, so you've got your website and it's got some users with the weak passwords, and somebody's going to try to guess them, and you'll get 3 guesses from here and 5 guesses from there, and that might play out over months, and you never notice it until they start cracking accounts. So the threat landscape, I would say, is probably the worst of it most of the time is state-sponsored. That would be my view. I mean, attribution is hard, and we can talk about that as well. But then you've still got obviously a lot of organised crime as well. But there are, as I was saying, there's a couple of governments which are really operating effectively as organised criminals. Some of them actually, directly seeking to make money as a legitimate, not legitimate, as an actual source, a revenue gathering strategy for the nation, is to conduct cybercrime. And there's a couple of countries that you can probably think of in that category. So it's pretty, in terms of, if we summarize this, what does the threat landscape look like? It's increasingly very well resourced. It's very professional. And we're starting to see techniques emerging which are specifically designed to evade your traditional defenses, to fly under the radar, and to achieve the aims of the attacker. And the aims of the attacker is usually either make money or sow the seeds of discontent. And those are, or steal intellectual property. Those are probably the three big ones.
And in terms of attacks, largely like SQL injection, command injection, are those the two kind of favorites for actually hacking in, other than password stuffing?
It would be, there's, so if we look at the data which we can get from a report which comes from Verizon. So Verizon, big US carrier and security services organization, has a really nice data set that they publish in the Verizon breach report. And so almost, let's say, 5,000 odd breaches that they've surveyed, of which about 1,500 of those actually had data loss in them. It's a really nice data set. Around 45% of those were as a result of web applications being breached in some way. And of those, about 85% of that is just due to stolen creds being used. So it's the biggest single category of how breaches are really happening right now. And it's well, I say it's easy. I mean, it's comparatively low tech, but you've got to, in order to do this well, you have to do those things I was talking about of distributing it across many IPs and so forth. So there's a lot of professionalism that goes into the really slick APTs, as they're called, the hacker groups that are doing this. I think that problem alone is kind of, that's number one for me. And then I would say the second largest category, or Verizon would tell us that the second largest category of web application breaches is through a CVE or a known vulnerability of some kind. And so that's where you get into what you were talking about, the SQL injection, and there's many others as well. So there was very recently, there was a vulnerability called Log4Shell, which a lot of people would have heard about. It became mainstream media. It was like a kind of 10 out of 10, really, really serious vulnerability. And this was one of those ones that comes around once in a while where you can breach a server even without having a password, and just even off sending a single request to it. It's really bad. And a very, very large number of hosts on the internet were vulnerable to this. So hence why it got a lot of media attention, and quite rightly so. What we saw was that the two major nation states that I think would first come to mind were really quick on automating, and they were very organized at quickly exploiting this vulnerability after it was announced. In fact, I think it was a Chinese researcher that I think actually discovered that vulnerability. I could be mistaken.
I think you're right.
You'll probably tell me.
Yep.
So, but it was disclosed.
I think he got in very serious trouble as well.
Pretty interesting, right?
Yeah, very serious.
Very serious trouble for disclosing it and not just keeping it as an advantage.
Yes.
Which, yeah. So you've got
a researcher out of Alibaba, if memory serves.
Right. Okay. So it was, wonderful for everybody that this was disclosed, and you've got to wonder how many of them are not being disclosed. But in any case, so very quickly it got picked up by, I think that it looked to me, again, attribution is hard. It's not an exact science, and you can't always conclusively say, this is definitely that government. It could be anybody, and there's false flag operations and whatever else. But it looked to me like government traffic, which within a matter of hours started exploiting this at massive scale, just right across the entire internet, just hosing traffic across all these websites and attempting to breach it. So we had to be very, very quick in responding to that. And that means respond to it and get that response in blocking mode in front of all the apps really quickly, and then deal with any false positives and compatibility issues and really get it rolled out fast, because it took off very quickly. So that was where, that was a good opportunity for our team to stretch their legs. And I think this is, we like it when cases like that obviously give us the opportunity to be able to to deliver some sort of mitigation at scale that makes a big difference. It's pretty satisfying for the team.
Yeah, that kind of leads me to the next thing I want to talk about. There's a difference between having something that one could deploy,
right,
and there's something where you just flip a couple switches and it's on. And it's on, and you didn't necessarily know this vulnerability existed 10 seconds before, and you take a look at it, you're like, oh, that's what it looks like. You insert it, and suddenly thousands and thousands and thousands of apps are all of a sudden totally secure.
Yes.
That's pretty amazing, first of all. And I think it points to something I like to call enterprise readiness. It's a difference between, you could do this, again, to your point, pushing back to the developers, pushing back to the engineering team or the DevOps team. Well, here are some mitigations. You have to install these patches. You have to go hunt down the SBOMs, software bill of materials, for all of your apps and all the things that might pull from logs anywhere, and go do all this work. Yeah, you could totally do that. Maybe
for a couple of apps this week.
Yeah,
maybe.
Right. And so, like, all of that advice is, it's well-intentioned, it's good advice, in quotes, but it's just not practical. And there's a big difference between what I like to think of as true enterprise readiness, where I decide I need to do this, and now the capability is there. I just press a couple buttons and boom, it's done. That's so much different than walking around with a USB stick, plugging it into computers or whatever.
Reacting after the fact. Yeah. And so we've got written up on the wall in one of our offices. This is kind of cheesy, but security geeks love this stuff. But there's a quote from Sun Tzu, the Chinese general, which is probably badly mistranslated, and one of your viewers will probably correct me on this, but it's along the lines of that you should subdue the enemy before the battle. Mm-hmm. And ideally, if you can harden your systems well enough, then actually people leave you alone. And I have noticed this, but what you're talking about, enterprise readiness, is absolutely key. So you've got to be ready and prepared. So somebody's on shift, somebody's watching Twitter, somebody's watching the news feeds. When the next Log4Shell comes up, we've got somebody whose job it is to notice, and then to identify how it works, and then to come up with a mitigation strategy, and then to put it on the system and roll it out. And the cloud team know how to get these things rolled out quickly. And all of that has to be set up well ahead of time. Now, we don't know what the next Log4Shell is going to be, but we know that if we do all the groundwork to get ready, then we can push out a fix for it really, really quickly. And we know that if there's some sort of problem and we caused a compatibility issue with some app, then there's a separate team that can handle those influx of queries, and all that stuff needs to be set up ahead of time, right? Mm-hmm. And what we do find though with, I see a really big difference when we first often get in path. We'll be in a kind of a transparent, like a listening only mode, and we just want to watch the traffic for a while, make sure we don't break anything, and just figure out how the application works. And this is largely done by machines, but humans will also supervise all of this quite directly. And we see that when we first get in path, let's say we were working with this a financial giant, a really, really big finance organization that had this old application, and we got in path with it, and it was vulnerable to SQL injection. That's very much still a thing. Mm-hmm. And straight away we could see how much of it was going on. I mean, people were just kind of having a field day downloading this organization's database. It was right from under their nose. And so as soon as we were able to get in path, identify what's going on, and then we got to step through change control. We got to go, okay, guys, this is pretty serious, but we need to act right now. We need you to approve us. So we're going to go into blocking mode, and we stop all this bad stuff from happening. And then it dies away and it doesn't come back. And there's a really, really big difference between the ones where you're blocking and stopping, and the attackers, they sort of see you, they see the security team blocking them, and they get the impression, okay, somebody's paying attention here, I'm going to move on. And so that kind of hardening is very discouraging to attackers. And I think if you've got systems that are sitting there that are advertising old versions of SSL and all the things that old systems do, it's kind of waving a red flag to the internet saying, attack me, I'm easy. And it really does attract a lot more attack traffic than when you've got it. You get even just your basic hygiene, get it really in good shape, then not much of that stuff arrives anymore. It changes a lot. So I do think that preparation ahead of time is key. That's super important with DDoS as well.
Yeah, we can certainly talk about that. One quick point about the enterprise readiness, that so a lot of people are fearful, as you said, especially old-timey network people, that if you put these devices in line, your network's going to go down. Like, you can't handle the amount of traffic. I remember back when I was at eBay, we didn't have firewalls because we would crush any firewall. Like, firewalls were just not an option. However, we did have F5 devices, like a lot of them. That's what we used to do all of our load balancing. And this really is the same technology. And I think that when we're talking about the scale of the internet, if we have to get to the size of, you know, thousands or tens of thousands or maybe even millions of customers, you do have to have that sort of high performance stuff that the true enterprises are going to have tons of traffic. I remember when Victoria's Secret had one of their big launches or whatever, just their normal traffic took their website down. Like, they didn't have good caching, you know, they hadn't done the right things ahead of time to protect against themselves. They sort of had the slash dot effect. They took themselves down just by being something that a lot of people want to take a look at. Like, that's a problem normally. And so people will get fearful about anything in line. But I think this, you know, plus a bit of caching, I mean, could actually save your company. It can actually make that problem less than more, if that makes sense.
It can. And there's, it gets quite tricky if you think about, I've got a couple of examples from internet banking. We look after a few internet banking sites, and they get pretty commonly attacked, as you'd expect. I mean, they're literally, you know, they've got money inside them. So we see a few things happen. Now, one organization that we worked with, the application when we first started working with them was only able to handle about, if you can believe this, about 20 requests a second, which is fine for the, you know, it's a fairly,
that's only a handful of people hitting at the same time.
It is, but but that was all it needed. I mean, it was a relatively small bank, I guess, and, you know, maybe around end of month, a few people would hit it, but it just wasn't, that was sufficient. But the issue is that, you know, if you imagine you can load up this web page and you hit F5 and refresh the browser, if you hold your finger down on the F5 key, you can DOS them by yourself. I mean, it's actually really difficult to defend an application like that, because what would happen, well, one thing that happened actually was this organization was being troubled by a series of attacks, and there was a news story on TV News, and it was, well, such and such a bank has had an outage today. And then a whole lot of TV viewers all pull out their mobile phone and go, "Oh, is the bank down?" Well, it is now. So that kind of effect. I mean, how do you treat that traffic? Because it's unwanted and the site can't handle it, but it's not a malicious DDoS. It's just a DDoS. So if you think about, okay, well, we're going to use technology to protect against DDoS attacks by somehow handling this. Well, we're going to tell the difference between people we like and people we don't like, or kind of people who are customers or not customers, or, you know, it's sometimes it's tricky when you get to that kind of point where you've got a lot of browser traffic, way too much for the app to handle, that you can't really use technology to tell the difference between the browser you want to accept and the browser you don't. Certainly not to the same extent. It's not something that you can just kind of jump in line and go, "Oh, that thing's a bot, I'm going to block it." And so, I mean, you've got to work with organizations, like you talked about caching. So that's a technique we talked earlier about content delivery networks and storing content at the edge, and that's certainly very helpful. But when we see an actual a login request per second attack, and this is another example from online banking that is related, we had a login page that was getting about 2 million login posts per second. Which is a really, really large number, right?
Yeah, no kidding. Even a really fast machine can only do 2 million in a day.
Right. Yeah. It's absolutely vast amounts of traffic. Yeah. And this is one thing that I absolutely love about cloud provider environments that we're moving into, that are now actually where you're deploying what's called sort of serverless. And I used to, I guess, bristle a little bit at the term serverless, because we all know there's servers underneath it. But okay, serverless, all right. I guess what we mean by that is that
you don't have to run the server
yourself. You don't have to run the server yourself, and the cloud provider will scale it for you. So if I want an application load balancer that can do SSL and it can save me from DDoS, then it's up to the cloud provider to make it big enough when it needs to be. And in fact, we've seen that work really, really well. I mean, those 2 million login posts per second, we were working with a cloud provider vendor that we use, and just watching the graphs and just about in disbelief. There's just so much traffic, but the application's actually still able to function. Those types of attacks.
But one of the problems with that, you can keep it up, but what might be happening behind is it's scaling like crazy.
Yeah.
And so, yes, it stays online, but you've just
At what cost?
Yeah, what cost?
Well, I know at least one cloud provider where you write them an email and you say, hey, this was an attack, and then they take it off the bill.
Oh, that was nice.
So look, I think that's I don't know if everybody gets the same deal, but in this case, that's how it's handled. And also, it varies from one cloud provider to another. Some don't charge for bandwidth at all, and some will charge only in one direction. And but usually, it's designed that if you're going to get hammered with a DDoS, you don't get a monster bill, and by some means or another. So I'm sure there are cases where that could go really badly, but
I've almost caused a number of those things myself with some of the technology I wrote. You'd be surprised. It's kind of like there's that building, I forget where it was, that's kind of curved, and it's kind of curved like towards the street, and so the sun would hit it and it would focus all of that energy down onto these cars that are on the street, and they'd just melt these cars. It's kind of like that, any one machine is just doing its job, and now you multiply that times 100 machines, and they're all just doing their job, and it's just nothing can handle that.
It starts to become very, very large. Yeah. Yes. So we're seeing what you inevitably see in cases like that. Again, going back to the Sun Tzu thing of subdue the enemy before the battle, but so long before that attack takes place, the attackers, we're starting to see now that they're doing a lot more research and a lot more homework, and they're probably also getting really efficient at doing that. Just got automated tools for doing this, for probing your infrastructure. But somebody who spends even just half an hour taking a look at your organization and how it's put together can see, okay, you've got a legacy data center over here, and that's sitting on, you've got your own ISP links running into your own firewalls. This sounds like so many operations, right? And we know that ISPs, they might have some degree of DDoS mitigation capability, but they're not scrubbing providers, and there's usually limits to this. And so the attackers will say, okay, I can see a data center over there that I can completely flood. Now, even if you've got a CDN sitting in front of it, I can still knock out the back-end application. And actually, even if the firewall's locked down, I can still knock it over because it's connected to the internet and I can route directly to it. And sometimes it only takes, if the organization's got gigabit pipes or even 10 gig pipes, they're really not hard to knock over.
Right.
Increasingly we're getting enough bandwidth from our home accounts to be able to do that by ourselves.
And there are tools now where you can just probe the entire internet and find out where people are, and then they go to a cloud provider, and if they haven't protected that original source,
you can see where it used to be by looking at the DNS history.
Yeah. Yep.
And actually there are tools that'll go out and scour the internet, and then you can just simply search those and find out what you need. You don't even have to do it yourself. So that's open source intelligence, right? So what we're seeing is, how does this play out when an attack actually occurs? It'll be something hits you and it works and you're down. And they've studied you, found a weak point, and that's what they'll hit first. And so then everybody scrambles. It's like, all right, okay, we're going to deploy DDoS scrubbing capabilities. And for the network guys, you'll know it's BGP GRE tunnels, as they're called, and you advertise your networks out through the scrubbing center. And so that kind of model, it'll take hours to days to get this in and get it working, and meanwhile the organization keeps getting hit again and again, and the board of directors is upset, and it's all on TV. And so then you get this in place. Great. Okay, then now immediately it switches to, but you've left your DNS server open, so start hammering that, and the team has to go, okay, now we have to move all our DNS servers into the cloud. What are we going to do there? And that takes ages. And then it's like, okay, now we're going to hit the login page. And so you just move from one attack to the next, to the next, to the next. And the attacker is prepared with these techniques and knows what the next technique is and knows that it's going to work. And so as a defending team, a lot of organizations will end up sort of scrambling behind the play. And if you think about, okay, how can we get ahead of this? Well, let's take an attacker's mindset and go, how would I knock my organization over? Well, you can you can look at where the infrastructure weak points are. You can test those. And you hear a lot of things like, my firewall blocks DDoS. I saw it on the data sheet. I think we're fine. My ISP, they said they've got a DDoS thing. I saw it on their website. I think we're fine. But when you actually go to test these things, they really don't work. And usually when we're working with an organization who wants to get really, really hard at being no longer DDoSable, there's usually a number of iterations, because there's surprises that turn up to the team. They don't really realize that this technique was a thing and that it works and how easy it is to do, or that that the mitigation that they had in place wasn't really sufficiently tuned properly, and that there's another technique which is going to work, or another. And you've done a lot of research in this field yourself. You know, there's that that there are techniques that are designed, I guess, to surprise defenders, and novel techniques that work, and they require different approaches. And doing this in the heat of battle is really stressful.
Yep.
And everybody ends up working crazy hours, and as a service provider working with them, you get to see what it's like at their end. And you're sitting on a call with there'll be infrastructure people on a call at 3 a.m. and they've been working for 40 hours trying to get this thing and get it working. And it's a stressful time. Whereas if you have a controlled program of work ahead of time, those events never come. They don't happen, because the attackers will they'll look at your perimeter, they'll go, I don't see any easy opportunities here, and they move on, and they target someone else. It's a case of, you don't have to outrun the bear, you just have to outrun the other hikers.
Or just work in the video game industry, and then you don't have to worry about that. No, they get it worse than we do.
Yeah, or online gaming.
So one of the other benefits, I think, is you don't have to rack and stack anymore at this whole design.
Yeah.
The old way we used to do this stuff is you had to physically go to the data center, find a slot, a couple use slide this thing in, configure it, try to get it running for, God knows how long, and then kind of the flip of a switch, hope it all kind of works. And,
And you remember how that happened. I mean, back in the day, you'd go to build a firewall and you have to buy the software, and then you have to buy the hardware from 2 different vendors and build it. And then someone comes out and goes, hey, how about you just buy it as an appliance? Oh, that's so easy. And you just rack it in,
It was never easy.
Well, it was easier, let's say.
Easier, yeah.
And then, then everything became virtualized. And now, where we're at today, which is where you want to build an application and you just write a file that declares what you want, and you hand it off to the provisioning system and make it so. And it just gets built for you. And I didn't tell you how big to make it. Well, make it as big as it needs to be. Just, scale to the traffic, scale to the attacks. And that's nice. I mean, it can be an expensive way to build if you've got a really big app. I mean, eBay, for example, are not doing this on commodity public cloud like this. You've got to cost optimize if you're at that sort of scale.
Yes.
But for the average organization where you've got a ton of apps, not many developers, or not the developers are too busy, they have to work in a very efficient way. Then you take that easy path and just outsource all the infrastructure. And I think that's been to everybody's benefit.
I think so. So I think it's probably worth talking a little bit about the skills gap and how this relates to your product, because I've been talking about this for quite a while now. I don't think, and I'd love to hear your take on it, I don't think that we're going to be able to hire our way out of this problem. I don't think that, you said, I don't know how many, 1.5 billion apps or whatever it is out there. I don't think we're going to get from call it a handful of tens of millions or whatever developers to 1 billion developers. I just don't think that's going to happen. Maybe ChatGPT can make this wildly better, but I really, really don't think so. And there's a lot of legacy apps out there, et cetera, et cetera. But also, these are very complicated things that we're talking about. And even somebody who I think is relatively good, I still probably wouldn't put them in front of a WAF and just say, go for it. Right. I still wouldn't do that. Even if, 5 years experience, I probably would still be like, I'm still going to have to babysit you until I'm pretty sure you know what you're doing, because one ACL wrong and the whole site goes down.
Yeah.
And so to me, you have to have a centralized system like yours, where you can have the best of and the brightest, and you can hire them from all these random places. Because I run some little mom and pop jam company or something. I am not going to get the best and brightest security guys working on my F5 device, which probably costs more than my entire jam company even makes, right? These are like $50,000, $100,000 machines, right? They're incredibly expensive for the low end ones. I'm not going to be able to do that enterprise level security, despite the fact I'm getting hit by the same kind of enterprise level problems. I'm still getting hit by SQL injection and command injection, by arbitrary things running around the internet. So if you don't have this centralized company who handles all these really complex, hiring the right people, getting the right technology in place, deploying it in an intelligent way at scale so that you're taking the brunt of the cost and splitting it up across lots of small companies, I just don't see how you get out of this problem. I don't think you can get 500,000 more developers a month until we get this problem solved, who are good enough to put in front of a WAF. I don't believe it.
Well, I think I'd agree. So where we're probably seeing the difference being made is if you can create a specialized operation, which is just doing one thing, and in our case, it's just web apps and API, and there's plenty enough there to keep us busy.
Yeah.
But we're not straying off into other stuff, desktops, managed endpoint and so forth. They're all completely different areas to me. If we stay totally focused on one thing, then we can develop an economy of scale. And it happens in a few different ways. One is by being able to share IP between customers, as we were saying before. But the other is also you get very efficient at training people and being able to bring on somebody who has, let's say, a strong technical aptitude and a good mindset, but not necessarily the exact background that would enable you to immediately leap into this. But then you can put them into a system where they're going to succeed and where you've got some safeguards around them. Like, let's say they're going to submit a change to a WAF, then a senior WAF engineer will review it and approve the merge. So you can get people working in pairs. That's one technique that you can use. And then in that way, somebody can become productive really quickly. So I think that really helps. And it means that you don't have to get kind of fully baked web security experts from straight out of academic institutions.
Which you're not going to get anyway. I mean,
right.
Really.
Yeah. Well,
there's like 5.
Right. Yeah. So our experience has been just, hiring for intelligence and aptitude and general interest levels. And then very quickly people can become productive if they're in the right situation and the right framework. And actually this is kind of end-to-end. Like we also have to work with customer organizations to ensure that the nature and shape of the program that we're delivering is very consistent and productized, so that the nature of the support tickets and the work and the deployments are all as similar as they possibly can be. And so you develop a system and a process that works, and it can be customized enough, but then it becomes really efficient over time, and you get good at training people how to do it. And you would have seen similar things from the work that you're doing in vulnerability scanning and other managed services.
And White Hat, yeah.
Right.
Back when they were a thing.
Yeah. And so
Synopsis now.
It's it's one of those things where, a little bit like penetration testing, is the human touch is still better than just fully automated. But person plus machine is the best of all, and the smarter the machine is, then the more productive the humans are, and scaling that smart machinery underneath us is what's enabling scale. And
also makes them less bored. I mean, if you're not having to work on the same stupid thing like 800 times a day, you're more likely to make mistakes, and you're probably going to quit.
yeah, that's true. And in fact, actually, keeping people moving and offering them career advancement, and we can't just be trying to run kind of operations that have too much repetitive labor. It's okay for a while, but everybody has to see that you've got a way out of that you're automating it away, that things are getting better all the time, because nobody's going to sit there in a data center just kind of clicking a button for their entire career. It's, so yeah, automation is pretty key. I think we're also, we get a lot of questions at the moment around the large language models and the AI stuff, which is obviously a pretty hot topic. I haven't seen that it's really caused a huge uptick in the quality of attacks that we're seeing. I think that most of the adversaries that we've got don't really need ChatGPT to write their Python scripts. I think they're pretty good at Python already.
Yeah.
And the really more junior or kind of first-time hackers and script kiddies who might say, okay, I want to ChatGPT, tell me how to hack the Pentagon. The kind of output that you're getting from that, they're not really able to suddenly elevate themselves to the, to the threat level of a nation state.
It doesn't take that.
So far,
speaking from experience.
All right. Okay. Well, so far, we haven't seen a tremendous impact on the nature or volume or quality of attacks as a result of large language models. However, they're really useful, and we love using them to do stuff like annotate my code and help me write this user documentation. And so it creates tremendous productivity gains, so we can serve more customers and do better with with the skills that we have. But that's then if you look at actually probably the real impact of AI and machine learning, which has been going on for a lot longer, which is already embedded in the network, and it's telling the difference between a good connection and a bad, and just really narrowing down that freedom of movement for an attacker.
Sure. So one of the things I think that your product, let me phrase it a different way. I think compliance is one of the most difficult things for companies to get their arms around. And there's lots of reasons for that. It's complicated. They're working with third parties often, a pen tester on one side, a compliance expert who's going to actually audit that you've done whatever the pen tester told you to do on the other side. There's just a lot of moving parts, and it's hard to do well. I think RedShield provides a really interesting service because you can just take that pen test results and go, wow, there's like 20 different issues here. And instead of basically handing it off to the poor dev who may not have written that app, they're just the dev who's there or the dev who's available or whatever, and saying, go figure out security and figure out where this lives in the code. And they're like, I don't even have access to the server, or maybe I do, but this is antiquated software, or it's compiled and I don't have the source. And there's a million reasons that this might be extraordinarily difficult. Instead of all of that garbage, you just say, hey, RedShield, go shield these, get rid of them, get us compliant. And that could be a handful of hours, and you're to the point now where you can go successfully pass an audit. That is super compelling.
So that it turns out that does play out that way, exactly as you've described. And over time, we've done enough of these projects that we've got the library that we can do it quickly and efficiently, like you've mentioned. And we saw one organization, which was a kind of a non-government but critical national organization, which had spent 2 years and around 20 to 30 million in development costs trying to fix vulnerabilities to pass PCI. And it was getting up to third strike. And actually there was still a ton of outstanding vulnerabilities. There was about 160 that they had left across 40, 50 odd applications. And I think maybe with, they passed it across to us and said, well, what can you do with this? And in the space of about 2 weeks, we took the 160 odd vulnerabilities. We discovered another probably 150.
Wow.
And we're able to mitigate all of them, and to go back to their pen testing team and go, okay, guys, we're ready for a retest. And they tested 100% of the vulnerabilities, and they signed off that 100% of them were mitigated to their satisfaction, that they were no longer exploitable at all. And the organization's able to pass a PCI audit. So that took all up, realistically, that was probably about a month. But that was after, and thinking of how much that organization had spent over the prior 2 to 3 years trying to do that with developers, with software replacement programs. And this was it really was a really, really difficult problem for them. And they were about to...
If you're hitting the 100 vulnerability mark, that's a pretty complicated app.
Oh, this is across 40, 50 apps.
Oh, okay. Got it.
This is the entire kind of risk register.
I have run across apps that are that bad, but
yeah, right.
Pretty rare.
Pretty rare. Not that many. So that does absolutely play out like you're talking about. But you think about, okay, so we're talking about economies of scale. Okay, let's think it down to an organization that has some relatively small team. Let's say you've got 5 security people, but you've got 300 apps to look after. And then security comes around, an auditor comes around, and it could be PCI, it could be HIPAA, it could be FedRAMP, or or an ISO 27001, and you have to demonstrate that you've got a plan to solve zero-day vulnerabilities and demonstrate that it works, and you've got a plan to discover new vulnerabilities when they arise, and a plan to stay on top of fixing and patching applications. And so even just actually demonstrating that you have a process for these things means that somebody has to write all the policy and process documents, and then you have to show them working. And so for us to be able to go, okay, well, you can put us in path, we can shield the vulnerabilities, and then we can test them, and where everybody's comfortable that they've been fully mitigated. But then we're going to run this ongoing program where we continue to discover new vulnerabilities and patch them when they arise. And we've got a document that you can give to your auditor to say, here's my process, this is how we do it.
Oh, really?
So next time a vulnerability
nice.
arises, so that's, this is what you get by specializing, right? Is that all of the things that are related to running a program like this can be done at scale for, and then for a smaller organization to be able to benefit from this, you just have to rent it by the month per app and not have to.
It really is pressing the easy button, isn't it? Well, I mean, having the policy document pre-made for them, and I'm sure that after a while, the auditors look at that thing and they're like, "Oh, it's RedShield. Oh, I don't even need to. You're good. Yeah,
that's fine. Yeah, and they can go look elsewhere.
Yeah.
So that's some of the advantages that we've had, but it has to be. It's both a platform and a technology thing. You have to build a cloud. You've got to have all the deployment automation. You've got to have the portals and the vulnerability scanners and all that stuff is there. But it's not just a software and a tooling service. I mean, it really has to be a security operations practice that continually stays on top of your apps, your vulnerabilities, your attacks, your reports, your change control process, your audits, and your conversations that you're having at board level to say, what are the Chinese government doing to us today? And to actually have one team that you can go to and service all of these needs in a sort of cost-effective way. That's really the vision that we've set out to achieve. And we're about 10 years into this now, and in a lot of ways we've managed to crack a lot of the hard problems, and it's just a case of just continuing to get it to scale. And
so let's talk about the injecting things, because this is actually where I get excited, because suddenly you go from just being a WAF, as if that isn't already pretty interesting and useful for all kinds of things. But now you can inject other things, like I was saying before, new HTTP headers. And that, once upon a time, there weren't very many interesting ones. And now there's tons. There's cross-site scripting, breaking technology. There's content security policies. There's anti-caching headers. There's all kinds of things you can add that have interesting effects, not to mention other people's technology. So can you give me some examples of what you're able to inject?
Yeah, so there's a lot of cases where you would want to inject other types of technology. So say, for example, you want to deploy a really smart capture in front of a login page, and you've got a file upload and it needs some sort of anti-malware. This is where we start plugging in third-party technologies. Now, you still want to just cut it in path in an easy way, just put the traffic through some sort of cloud service. But when a file upload comes, it has to go off for malware scanning, and then if we see more than 3 failed login requests, we need to present a really decent capture or some other types of technology like that. And it's quite nice to be able to have a practice where, so our team is really, really good at working with an organization to get a large number of applications cut onto a network proxy service, managing all the certificates and getting all the traffic flowing to the point that we can now start doing some really good security operations. That gives us now the ability to say, okay, we can plug these additional tools in. And so actually bringing additional vendors into the ecosystem it's certainly a very interesting kind of opportunity. And there's a few that we've worked with. There's been the Arcos Labs, and there's been OpSWAT, the AVs, and also Duo on the MFA side. We were talking a bit before about anti-bot, and this is where we looked at organizations that are having difficulty with the drive-by, either web scraping, people stealing content off the website and going publishing it elsewhere, or people trying to guess passwords and crack accounts, all that sort of automated activity. We were looking for solutions to that, and it used to be a fairly easy problem. I think going back, I don't know, maybe 10 years. I'm getting old. So all you had to do was just respond back with a JavaScript. And if it was a bot, it would break. If it was a browser,
I remember that technology. That did not work at all.
Well, initially, I mean, it worked just fine. But the problem is that it wasn't long before, I mean, the script, the bots.
Let me take issue with this one.
Okay.
I really do not like that technology. I didn't like it at the time. I don't like it now. Basically, so everyone likes that analogy about running faster than the bear.
Right.
You can't run out the bear. You can't outrun the bear, but you can outrun the guy next to you, and that guy gets eaten, and that's great. That implies the ecosystem only has one bear, and that there's one person you could feed to the bear, and that the bear will never be hungry again. And that is just not how the internet works at all. And the closest analogy I've been able to come up with is what I call the prairie dog analogy. So prairie dogs are kind of these rodents, and they kind of sit out in these fields and they kind of look around, and if any other animal wants to get in their hole, they're like, no, hell no, and they beat them up and try to get rid of them, right? But the second they hear a hawk or the second they spot a fox, they dive in that hole, and all comers, anybody who wants in that hole, they get them in there as quickly as possible. And as a result, what ends up happening is they starve the predator. You bring the predator in, right? And so when I started thinking about that kind of analogy about how the whole ecosystem is actually working, where you really do have to starve the adversary, I started thinking about, let's say you have a snake oil technology, totally doesn't work, it's not real, but it makes you do one extra thing to get past it or whatever. Well, you employ it on some website, and this technology is now deployed on 50 websites, and the adversary is just going around hacking all kinds of stuff until the day they see their profits going down. They're like, okay, I actually have to look at this thing now. They go and look at it. And meanwhile, this snake oil salesman going around selling this thing to all these different companies, making tons of money and proving that indeed the bot traffic goes to zero. It's like, wow, look, it totally works. And everyone's like, and they have all these testimonials, and everyone's happy. And meanwhile, the bad guy just ramps up his attack on somebody else. So everyone's like, well, and my attacks are getting horrible to the point where, okay, screw it. I didn't like this technology before. I'm going to try it. They try it. And what ends up happening is it redistributes the load across everybody when the hacker goes and takes a look at it. And they're like, you know what? This is worth trying to get past it. Oh, I have to do one extra click to go past it. They go and they do that one extra click. So the entire industry goes back to the way it was. So everyone saw an uncorrelated up and down of their traffic, but they think it's correlated to just like random internet stuff going on. You know what I mean? Like, oh, it's just, the hackers figured some crazy other thing out. And this whole technology was garbage to begin with.
Well, so I won't have an opinion on this. So this is what I did see, go back about 10 years ago, was if you're getting hit by things like these are literally like just curl scripts, and if you fire back a JavaScript, you could shut them down and they'd go away for a while. Okay, for a while, like I say. So what we just done about a year or two ago, we had a customer who came to us and they said, all right, we've got major technology vendor X, and they've been in and they've switched on all the anti-bot mitigation, and we want you to come and test it and tell us how we're looking. And so we took the opportunity and we said, okay, let's also try vendor Y and vendor Z, and we're going to get a bunch of these. Let's run a bench test because this is going to be fun. And so we got the JavaScript technology guys, and we got the AI guys, and we got the cloud WAF guys, and a couple of those. Mm-hmm. And we lined them all up against this another online bank actually, and ran our testing. And we'd found so these are either set up by the vendors themselves, or we'd set them up according to their instructions and been in contact with the vendors and said, okay, how do we? Because quite honestly, we really, really wanted this technology to work because we needed this for our customers to be able to solve this bot problem.
That makes sense,
right?
You're giving a fair shake.
Well, we did, but I mean, we're also we wanted to give it a really good kicking as well, because we know that our real adversaries do. Mm-hmm. So what we found was, honestly, it was disappointing. It was, okay, all you had to do was, well, the problem was that, the bots used to be just curl scripts and wget and whatever. Mm-hmm. But nowadays it's really easy to use headless browsers to do things. So headless Chrome. So this is a browser that you can run on a command line, and it's quite efficient. And then you've got a script which can control that browser and get it to do things. But it behaves exactly like a real browser does. It is a real browser. If you send it JavaScript, it's just going to run it. And so you've got to be able to tell the difference between a browser run by a human and a browser run by a machine. And then if you get the machine to just do a couple of things, like it'll do some little random mouse movements and a little bit of variation in the timing, which is really easy to do with these control scripts. This is super easy. I mean, it took one of our researchers kind of half a day to get this working. And now, unfortunately, well, we find actually that you can just kind of breeze through this stuff. And so this was disappointing to us, because we really wanted a solution to detecting bots that would solve that need, because a lot of customers ask us about it. And we came to the conclusion that actually really all we can do here, I think, is actually MFA. And so especially for, and this is specifically with reference to the login page to a high value app, like an online bank, or I guess any login page to some sort of important business system, and the problem of credential stuffing. And so now if you run a trace across, say you take organization X and they've got, you can discover 3,000 domains, and you can just run a query across all of them and see which ones have got login pages, and you might find 120 of them do. Now, how many of those have got MFA? Well, some of them have got single sign-on, and they're going back to to a Microsoft AD or something like that, and so you've got a good solution there where you can put MFA in. But there are a lot of applications that have login pages that have no developers, and they've got a big database full of users with passwords of all kinds of varying quality, maybe stolen, lost passwords, too short, etc., etc. So same problem as you have with legacy code anywhere, where a lot of legacy apps, not enough developers to fix them all. How are you going to get MFA across all of those? And we've found there's two parts to this. One is if you've got very high value, let's say very high value users, like staff members. If you've got a couple hundred staff members or some containable number of people, you can give them hardware keys, and that's the best of all. And then there's other systems, like maybe a token, software client on your phone. There's pass keys obviously are becoming, that's probably more on the consumer side. But if you think of something like an airline loyalty program where you might have several million users, you can't be issuing keys to everybody, hardware keys. It would be cost prohibitive and logistically just completely out of the question. And in fact, in a lot of cases, you can't really be rolling out mobile phone clients either, because you've got people who are, if you think of local government, you might have people who don't even own a smartphone, or there are people who might have one but they share it around a family, or you've got a lot of variation in the amount of capabilities of the user base, but you still have to protect those accounts in exactly the same way. And so what we've found is that actually the really practical solutions are usually the easy ones, SMS or email. And SMS is kind of a little out of fashion for a couple of reasons. One being the SIM swapping, where you can intercept somebody else's message, and another being that it can also be used fraudulently to drive revenue for crooked carriers, which is a kind of an interesting thing. It leaves really only email, in my view, as being the easy one that you can roll out without having any kind of onboarding ceremony, without having to install a client, with no posting keys around. And it is absolutely strong enough. It's an excellent solution to stopping credential stuffing, which, as we said before, is the number one way in which apps are getting breached. Mm-hmm. So if you think, okay, what can we practically do that's within our control to get across those 120 apps that have login pages that have no MFA, and we don't have a dev team that can rebuild them? I'm not going to plug them into Active Directory. I'm not going to swap out their user database for something else, and we're certainly not going to roll out mobile clients for everybody. You will generally know everybody's email address that's using it, especially because it's usually the username, or you can get it out of the app. Send them a magic link. It's a little bit like the passwordless idea. You send out a magic link to the email, mm-hmm. and this can be rolled out really easily and really cost effectively. So by putting that in, again, in a proxy sitting in front of the app, we inject this code which intercepts the login request, checks to see if it's a legitimate user, sends off an email to a magic link, and then registers their device, is something that we can now roll out quite easily because we developed it for a couple of customers, and turns out actually a lot of people have the same issue. And it's what we're talking about before, this kind of economy of scale when you start working on a problem like that. So we've been doing a lot of that. I mean, long story short, we've found that if credential stuffing is the biggest cause of breaches right now, and bot detection technology has, in my view, pretty serious challenges, and I question whether it can work in the long term, it really leaves us just with MFA. And of the MFA, which is practical, achievable, and low cost, email is the one which is actually you're able to roll it out really quickly. And there'll be people that disagree because there's also the problem of phishing, and that is a serious issue as well. But if you think, well, okay, right now I know that I've got applications which are at risk of getting cracked. There are bots guessing passwords right now, and we can maybe even see that. And you think, how are you actually going to approach that in a practical way? Being able to roll out easy kind of no code. I mean, there's code at our end, but there's no code for the customer. And to be able to deploy that across a whole bunch of different apps. And so that's where, before we were talking about a WAF, does it just see and block bad things, or does it inject some stuff and kind of interact with the app? And I think there's a point at which you're getting into plugging in third-party products, like you say. But yeah, that's Sam,
that's so cool. I mean, it really is cool. I'm just thinking about the hundreds and hundreds of apps I've been involved with, and the developers are like, I don't know what to do. I mean, I don't really know how to fix this, and I'm trying to help them, and I'm trying to help them. I really want to help them. I'm not the developer, and I'm not going to, there's a lot of financial risk associated with getting in those apps. So I can't do it myself, but what do I do? I mean, I can't tell them to shut the entire app down, and yet that is exactly their option. They don't have the access to do what they want. A lot of times they really don't control the app. It's sort of like a third party they've installed. If they make any changes, they void their warranty, and they're just sort of stuck. And even a traditional WAF, it'll get like, 80% of that stuff, but it's not going to get credential stuffing. That's not in its wheelhouse. So that's like a lifesaver for some of these apps.
Yeah. And look, 80% is being super generous.
Yeah,
like by a factor of 10. I mean, yeah. The other thing we found as well is so think about we're talking about injecting headers and fixing SSL. It's really technically really easy to do. You just go, okay, switch on better SSL.
Super easy.
Done.
Yep.
There we go. Okay, but if you've got 500 apps and they're all running old versions of SSL, some of them, if you upgrade that SSL, you're going to break things. And it breaks kind of silently, and you sort of don't know at first. But then until your major client calls you up and goes, hey, I've got 500 hardware stores that can't hit your, business service X because, well, my hardware client in the stores doesn't support new SSL. And it's just breaking. It might take an entire day of everybody's hair on fire to figure out what's gone wrong. But all you did was just try to upgrade that SSL. So, it's same with, removing headers. You can break stuff really easily if you don't do it carefully.
Of course.
So it's quite easy to say, okay, we've got vulnerability scanners, we find the problem, hand it off to the WAF, click, and now auto fix, but also auto break. And that's why I think that type of completely end-to-end automated program has been challenged because of the risks that it causes. And there's a view that developers are kind of adversarial to security people, and I really think that developers would love for this sort of program to just work like that, but there's just the risk that things could break. So a practical approach is, all right, let's watch the SSL for a while. Let's see who's negotiating old versions and figure out, is that desirable traffic? It could be customers, or it might just be junk on the internet, and we're happy to switch that off. But you still have to go through that. And then you've got the organization's change control, and you've got to go raise a ticket with them and go, we want to strengthen the SSL. And we've checked, and we believe that with high confidence that we're not going to break any business critical traffic, and we want to do it on Sunday. Then, okay, then the customer just has to go, okay, all right, that's an easier conversation. But until somebody does all those things, you're stuck, and you're just stuck with this old version of SSL. So even what seems like a kind of a low-tech trivial problem, actually it becomes kind of an organizational one, and there's just a few things that you have to line up there to actually create meaningful progress. And if you go, okay, we're going to run a program of give us all of your vulnerabilities and we're going to make them better. You know, you have to navigate them pretty carefully, right? It's not just a technical thing. And it's, you know, technology is the easy part, really, I would say.
So give me the reasons why WAFs are not a panacea. There are some vendors out there who will say it solves every problem. And they'll literally put this in there. I'm not going to name names, but they'll literally say you don't have security problems after this. And I'm like, wow. Well, first of all, you're just asking to get really bad things happen to all your clients. But also, I don't understand why we can't have an honest conversation about what they're good and bad.
Right. Well, okay, you know, I guess I'm sympathetic to the challenges of being a technology marketer. You have to drive business. But no. Let's not give them any quarter. Okay. Well,
not on this podcast.
All right. Okay. So I think that in those organizations, you also have technical folk who are deeply uncomfortable with that message, but they don't have a loud enough voice to go, can we please stop saying that to customers? Because we're really, really overstretching. And it's an uncomfortable kind of reality. And I've seen that from a couple of organizations that we haven't mentioned today that I've worked for, where I've seen that kind of play out. And I remember going back to early 2000s, there were firewall companies that would say solves the OWASP top 10, and this always just makes me bristle, right? Because the OWASP top 10, for anyone who doesn't know, it's the 10 most difficult and persistent security problems in web security. That's how they make the top 10. And people think, it's just the top 10. We talk about it all the time. They sound really familiar. Therefore, they must be solved ages ago, and we can just click a button and they're all going to go away. And reality is, you look at them, it's like broken authentication. Well, there's 100 different ways that authentication can be broken.
That's a big class of issues.
It's really complicated, right? You can't just, there's no firewall that can just fix that thing. This is why this is, for so long, it's just been on the developers, because nobody else can figure out, how to make sense of this. But it's been very easy to make a claim and say, well, arguably I can solve one type of broken authentication in certain circumstances. So I'm just going to say solved. Number one, done. But, seriously, the reality is the OWASP top 10 is a difficult set of problems, and fixing it is a serious challenge. And there's also a ton of other problems that are outside the top 10 pen testers find all the time. So vendor claims are pretty tough. And the other thing is that you'd say my product, my platform, whatever it is capable of solving this problem, but it's up to you. And so you'll sell a piece of technology which if someone takes it and they deploy it really, really well and they tune the heck out of it and it happens to fit the certain circumstances, then yes, it'll solve that problem. But you can't just, as infrastructure engineers love saying, you can't just take the PowerPoint and staple it to the rack and it's done, right? There's the tools and the technology are the easy part. You can just buy them, but then there's the process and everything that has to come after that to actually deliver the result. And it's very difficult, I think, for a lot of organizations, even IT professionals that are consuming technology, to tell the difference between that thing I can buy has the capability, maybe if we run the right project and put the right skills around it, to deliver this result, or the result is actually what I'm buying, which is pretty rare. It isn't really that usual that you would actually be able to go, okay, I want to buy an outcome, make it so, and with any kind of warranty wrapped around it. It's much more the case that it'll be...
Do you guys have a warranty?
We do.
Oh, I didn't know that.
Yeah. So
I think we talked about that years ago, but I didn't know you actually gotten through with it.
Yeah, we have. Look, it's something that we've been working on for a long time. So warranting results is... How this works is we will warrant that if we understand a vulnerability, generally that the customer's told us about, we will warrant that the fix that we put in place is effective and that vulnerability is no longer exploitable. Now, there's things that you can't warrant. You can't say, and all future vulnerabilities, because they're unknowable, right? But we can say that when we understand a vulnerability, that we will give you a spec for a shield which is going to mitigate it, and that we warrant that issue is mitigated. And so it requires a conversation with pen testers as well. But we stand behind that and go, okay, we're not just switching on some sort of firewall feature that might approximately do the job. And then there's cases where there are vulnerabilities where you can't say for sure. Like say, for example, you get a pen test finding which says you have an old version of Apache. Okay, well, we can take out the header so you can no longer see that it's an old version of Apache. But what are those vulnerabilities? Often we don't actually really know. Or the finding is just, well, it's an old version of Apache, so we can shield it, but it's still an old version of Apache. You should upgrade it when you can. So I'd say, okay, look, that's a partial. You know, we can have some benefit there, but I'm not going to pretend that it's a 100% solution to that. But then there's others where we can say, okay, the pen tester will say your session token is too short. And we'll go, okay, well, we're going to pad it and encrypt it. And that problem is we've got a full solution to that. And 100% we'll warrant that. Mm-hmm. So it requires you to be a little specific, but it is absolutely possible to warrant a security outcome, provided that people understand what it is that we're.
I know Jeremiah Grossman spent a lot of time talking about this specifically. He's like, we have warranties for cars and toasters and, TVs. Why can't we warrant security? And it's because we didn't have enough data. And so many software products out there, they don't have a way to collect the data, and probably their software is awful. It's kind of a mix of those two things at the same time. But you actually get to see the outcomes of every single thing you're doing. In fact, you're basically fully on the hook for every single thing you're doing at all times.
Look, that's true, and it's we have to have a practical approach to that, because yourself, a system which is believed to be secure today, like for example the Java logging component. Mm-hmm. Tomorrow we discover that it is not secure at all. Things can change extremely quickly. And so, the future is, to that extent, is a little unknowable. And so we have to have really more things like process SLAs that says when those vulnerabilities are released and there is exploit code available and it is known to exist in your environment, we're going to prioritize that and we're going to act on it. We'll respond to your case under an X amount of time. You can't warrant the unknowable, but you can do a heck of a lot better than, I think, waiting until things go wrong to respond to those sort of scenarios.
What do you think is the difference between a good MSSP product security solution and a bad one? Like how would you define what to go look for if you're in the market for one?
I think a really effective MSSP product is quite specific and definite about what it does and what it doesn't do. So if you've got a service which is all things to all people, then the staff are likely to be overstretched and they're going to be winging it with too many scenarios to be effective all the time. You don't develop much of an economy of scale. The skill base doesn't really accumulate. Not specialized enough would be my view. And I think the future of this is that, and where we're going to see the industry move, is that you just have much more specific kind of services which are designed to stay in a certain field, get very, very effective at it, and plug in and do just that thing, and be designed to plug in an easy way, and we can integrate, or those services can integrate with the common programs like the business change control and with SOC and SIEM and those other sorts of interfaces that you have. But I think if you're, as a managed service provider, if you try to do too much, then you never develop that level of effectiveness. And you're really at risk of just saying, hey, yeah, we're going to watch your networks and we'll tell you if you get attacked. But then you plug it together and you just suddenly get absolutely flooded with a fire hose of attack logs. And what are you going to do with that? How can you really effectively, you can draw a picture of you had, 6,000 people did bad things to you yesterday and today it was only 4,000. Well, okay, how's that? I don't know if it's actionable. What are we going to actually do about that? And I think that happens a lot with where you've got managed service providers who are taking too much unstructured data. So accepting, for example, logs from any IPS, from any WAF, from any vulnerability scanning tool, from any pen test report, and as well as Active Directory logs, as well as endpoint detection, and hoping to make sense of that. And you might say, okay, well, machine learning's coming and it's going to help us by figuring out, joining all the dots, and it's going to help us
people are working
see
on
what's
that.
actionable.
They're actively working on that exact problem.
And look, and I think that's it's quite promising that might be possible, but right now I don't think that it's effective yet. It requires...
We're a week away.
Well, let's see. I mean, AI is moving pretty quickly, right? It keeps surprising us with how it leaps, which is fun. It's awesome to see how that is coming along. So,
but I agree with you. I think there's a lot of products out there that people want data from, and yeah, you're going to get some data off of it, but boy, it's just a ton of information you're going to have to process. So if you don't have some process on top of that process, some software automation on top of that, or just an eagle eye, it's garbage.
Yeah.
You're just creating jobs.
And for us, I think the key realization early on for us was that if we focus on vulnerabilities more than on threats, it's actually a more containable problem. So if you can discover the weaknesses and mitigate them, then you are less concerned with who is attacking you and less concerned with reacting at the time, because if you can see it, you stopped it. It's the prepare ahead of time thing. So
this is kind of a weird question, and let me answer it first so you can kind of see where I'm going with it. Do you think that companies should be in the business of security? Like the average random company, like a little mom and pop jam company. And I think the answer has to be yes. And here's why. It has nothing to do with like the traditional hacking issues, although tangentially it kind of relates to it. I think what ends up happening is every time you have any sort of software vulnerability or deficiency or some technical debt that needs to be solved, that actually is a hit to your valuation. It may not be obvious to the acquirer or the street or whatever, but it also could be completely obvious depending on what tooling they have. And right now, this technology is pretty early, but it's getting much better already, where I could basically take a website and tell you how many things are wrong with it without necessarily hacking it. But still, I can tell ancient technologies is probably not going to have this, not going to have that. Each one of those things is a ding because I'm going to have to go fix those things. So effectively, one cool thing that RedShield does is it can actually properly bring you up to where you think your valuation is, because without it, your valuation is probably significantly lower. It's just that no one realizes it yet. You might be able to sneak it in and get your company acquired before the bad thing happens, but it's going to happen statistically eventually, depending on the vulnerability, depending on what we're talking about. Or these technical debt issues, how broken your site is, you're throwing a bunch of 500 errors, or, you're not caching properly. So I'm going to have to build the caching proxy in front of it. Like, you're just wasting my time as an acquirer. I'm going to have to go do all this work. I think that companies, whether they like it or not, they're going to have to be in the business of security. Now, do they have to pay attention to it? Can they offset that? Can I give that to somebody else? I think that's a different and much more interesting question. But what do you think?
Well, what we've seen is in order to do so, and I guess I'll just comment only on the area of security that we are particularly focused on, web apps and APIs. And in order to ensure that you do a good job of mitigating those vulnerabilities, you have to have all of those elements that we had that we were talking about earlier with vulnerability scanning, somebody reading the results and somebody tuning the proxy sitting at the front and maintaining all of that and keeping that all kind of tied together as a program. Then in order to do that, I think for a small organization, we think you need about a minimum of 12 people to do that. Now, those 12 people may not necessarily...
There's just no way.
Well, they may not have to... So you might have 12 people, but they might be 50% available to do other stuff as well. But you have to have... You've got to have 24/7, and you've got to have, so there's a couple of different skill sets that you need there. It's really hard to do it with less than 12. So the options are that you could...
I talk to enterprises who sometimes have just one.
Right.
Just one.
And that's reality for so many organizations.
And these are big companies.
Yeah.
You've heard of them.
Yeah.
Like, there's just no way.
Okay.
They would never get budget for it.
So we think that by staying in our lane, as it were, and specializing, that we're able to get that down to more like kind of 10% of the cost of 12 people. So as an economy of scale, it works. Now there's a level at which it makes more sense for an organization to do it in-house. Think world's 5 largest banks. Mm-hmm. They're a market to themselves, and their security teams are more like security service providers to the different subunits and acquired companies and banks in other countries and all that. I mean, they're just a market on their own. Right. So they can build their own internal service provider to do these things. But very quickly when you get below that sort of size organization, it suddenly becomes really, really expensive to do well and not strategic. And it's a waste of resources that you could be using elsewhere. But I think, until recently, you probably haven't been spoilt for choice of where you would go to outsource this. So what we see instead is just organizations that will have the one guy that they can afford, and he's doing the absolute best that he can. He's working 18-hour days, but you're also accruing a lot of risk and a lot of technical debt over the years, and you end up with these perimeters that any pen tester will be familiar with this. You go and look at these organizations and they're just, there's red flags everywhere, right?
Yep.
So I do think, should organizations be in the business of security? Is it strategic to them? I think they have been out of necessity, and I think it hasn't really been possible for them to properly invest in that. And I think a lot of organizations are seeing the results of that. And you would have seen that at White Hat. I remember you used to publish a report about how vulnerable everybody is, and it's shocking numbers of vulnerabilities, and they take multiple years to get fixed. And the state of perimeters is pretty serious. And I don't know that that's changed really much in recent years. It's still very much the same.
Well, I think it probably has shifted to there being less vulnerabilities per app. And that has everything to do with modern web apps being a little bit more secure by design. But the old stuff, oof.
Yeah, still the same.
As a host, yeah, or maybe even worse, because now we found more vulnerabilities, more vulnerability types.
So I had a major national carrier, really big service provider organization, and we're talking about legacy software, and I'm kind of giving them the benefit of the doubt. I'm sort of saying, well, okay, maybe 20% of your apps, you've got developer teams engaged, you've got CI/CD pipelines, you find out about a vulnerability, you can fix the code, you can re-release it. And the security team said to me, Sam, realistically, that might be 3 or 4% of our apps. The rest of them, there is no dev team. There is no CI/CD pipeline.
Right.
I mean, we can fix things, but it's really expensive. It's really hard, and it takes time. And we can't fix everything all the time. We just don't have enough resource to do that.
Yeah.
So even for a major carrier, it's a challenge, right? So as you say, for a smaller organization, it's worse, and that's why we're seeing a lot of organizations outsourcing infrastructure, moving into cloud. It just makes sense for so many organizations like that, and also, that's been a lot behind the rise of SaaS as well, where hopefully, if all that organization does is just run one web application, then hopefully they keep it patched. And I'm being a little bit facetious, because I've seen cases where it doesn't quite play out that way, but yeah, I think more specialist organizations doing their thing and assembling a portfolio of service providers, it's becoming easier to do for organizations. You don't have to do it all in-house.
So how does somebody look at this bevy of options? Because there's dozens and dozens of options out there. I remember, I think it was Jer actually put on his Twitter feed, it's like,
are we secure yet?
Are we secure yet? It's like hundreds and hundreds and hundreds of companies, and are we there yet? Oh no, we just need one more company.
Just one more.
And so how does somebody take a look across the field? Like, what would you tell them? And how do you
well, I think
how do you choose
it's honestly, I think it starts from the board of directors. And as a technologist, I'm kind of tempted to dive in and say you need these tools and this thing. It really does start from the board, and the board has to decide that the organization cares deeply about the security of its customers' data. And that means that you need to then say, okay, well, are we appropriately investing in security? How much are we spending, and what are we getting for it? Is it effective? And we can get third parties to help us understand that. There is a framework for board of directors who are generally not technologists themselves to be able to say, okay, well, I'm going to plug in as part of maybe my risk committee is going to look at cyber. It's just another risk, right? You've got so many risks, from geopolitical and currency risk and reputational risk and all those different types of risks that a risk committee has to stay across. Cyber is just one of them. And you might say, Well, one way that you can handle this is by effectively offloading the risk to insurance companies. But cyber insurance is kind of an interesting and rapidly evolving market landscape, but it still feels like it's very early days. I mean, prices are very volatile. Not everybody can even get cover, and we're finding that organisations are getting hacked and that their claims are invalid because their policy specifically excludes things like legacy software. Well, you didn't patch that thing, so it wasn't insured.
Or you didn't tell us you owned it.
Or you didn't even know that you owned it. Which is a tricky problem, right? Because there's a lot of organizations that don't even know what they own. You were talking earlier about M&A, and I think that's around the time of an acquisition. Most very large organizations have often grown through acquisition, and you inherit these IT kind of estates, empires that are often in the years leading up to the acquisition, or the months, depending on how long this program goes, the organization will have been preparing itself for valuation. And usually that puts budgets tremendously under pressure. So if you can avoid replacing that old software system for another year, just kick it down the road. We're just going to cancel that project. We're just going to get rid of a couple of consultants here and cancel a couple of contracts there, and we're just going to trim the sails. And you end up just quietly accruing a little more risk over time than maybe you would like. And often I think an organization at the point that it gets acquired is probably in a position where its security is maybe at a low point. And then the new organization has to bring it on board, discover even what it owns, figure out how it works. It might be years before they really are actually able to get across this. So it's a pretty interesting point, I think, M&A. And around that time,
I think companies aren't worth what they think they are. I think valuations are wildly higher than the actual thing you're purchasing. I mean, unless it's just you're like buying IP or something. Yeah, fine. Right. It's what you think it is. But the technology is antiquated garbage, and it's very vulnerable, and it should have been done totally different, and it's gonna take you a long time to unwind it, and even longer if you want to keep it around.
So you're talking about technology companies specifically, or
yeah, sure, yeah. Let's say an average IT company that makes some widget they sell a product or service, right, or SaaS or whatever. I think generally speaking, once you actually look under the hood of what they've built, it's a hot mess.
Well, I guess I'm no investment specialist, but there's also a lot of capital that's looking for a return as well. And, there might be technology companies getting acquired where the acquiring company can drive a return through certain levers at their disposal, lower cost of capital or operational efficiency in the back office, things like that.
Well, so how do you define? I mean, I'm sure as you find your own issues in these companies, you have to do some sort of risk assessment on them. Like, how do you define a risk profile, or what's the value of this thing to the customer to bother thinking about this type of risk? Or
during an acquisition, you mean, to the acquiring party?
That would be an interesting way to take this conversation, but I meant more just on the average day when you find something that's, you're telling them, hey, we should really shield this thing, and they have to make the ultimate decision, I'm assuming. Well,
I guess we've got a framework for making decisions so we don't have to do too much we are able to make decisions using a structured method because we've made the same decisions many, many times. Like, should I remove that header right now, or should I go and raise a change request on the customer, or do I need to talk to the dev team? Those are my options. I know them to be the options. So we can, getting things like that done at that level is pretty quick and efficient once you've done it many, many times. Mm-hmm. But then there's other decisions like, should we, making investments in technology upgrades and.
So there's certain types of issues like eBay, for instance, since we brought them up earlier. They had a page where you could say, here's my product, where you could inject all the HTML and JavaScript and objects and CSS and images. And Flash movies and on and on and on, and PDFs, anything you could think of, you can inject into these web pages.
It was designed that day or that way, or it was an accident?
Well, okay. I think it was built and then they realized the problem with that design. But turning it off breaks 150 million items.
Right.
Like every one of them have like little flashing stars and whatever, and you're like, all this stuff is potentially vulnerable. So obviously we needed to fix it, and obviously we couldn't fix it because it's part and integral to the design of most of the auctions. So what happens when you're faced with weird circumstances where you have to kind of like, this is a business decision, it's not really a the technology fix is simple. It's like very, very tiny change and be done.
Right.
The real problem is the business. Like, how do you convince the business it's worth it, or how do you work with them? How does that process happen?
Well, I guess, all we could do is advise the business on how we think the risk should be valued and ask them how it sits within their risk appetite. I mean, it's really up to them and ultimately up to the board to understand what their risk appetite is. Because if you want to, if you said, well, we have zero appetite for risk, well, okay, well, let's just turn everything off. I think you probably have to have some appetite for risk. So what is that? Is it outside of the bounds of what you're comfortable with or not? And it's probably better, I think, to be able to bring the information to a board of directors to be able to make a decision as to this investment is important and worthwhile because this risk is outside our risk appetite, and the investment required to bring it back under control is favorable, then the decision can get made. And so it isn't so much the case of having to kind of, really, I guess, kind of wave the flag for security and advocate for security as being an important priority and so forth. I think the company already knows its priorities, but it's but I think the difficulty that a lot of organisations would have is they lack the ability to understand the extent of the risk, and they don't know whether it's within their risk appetite or not. It may be, like you talked about before, the application that you didn't even know that you owned, and it hasn't been maintained for 8 years, and it's super at risk of getting hacked, and it's got all of your customers' data in it. You don't even know about that problem, but I think once you do, then that's a pretty easy decision for a board to say, yes, it is worth investing in solving that issue, but it has to be raised in a way that's decision ready. And that involves just helping people to understand, okay, the risk is this, the impact is that, you can risk accept if you want, or you can spend X, here's one option, you could spend this and get that risk under control. So structuring it in that way is really, I think, the way to get programs approved.
Do you guys have some sort of TCO calculator? Like how do you, yeah. I mean, you already talked a little bit about augmenting staff. If you go from 10 employees down to 1 or 2 or something,
right? Like
what other sort of cost savings have you noticed?
Well, so again, obviously we, just within our specialized field. So the ROI models that we put together are from our own direct experience. This is how much it costs to do this well. You can, you've got option A and option B, and you can hire this many people and have this many skills, and they can handle that many applications and so forth. So we can put together a model like that, and it's pretty conservative, and you can model it one way or the other. And we've done this for our customer CFOs a number of times, and help them to understand, is this a cost that they could save? Is this something they should insource? Is it, and helping customers to quickly, be able to assess that has meant that we've put together ROI models, which are, in fact, some of our customers have actually worked with us pretty closely on putting those ROI models together in their own formats and frameworks, and allow us to reuse them, which is really helpful.
Out of curiosity, I know they're trying to mitigate against downside as their primary use for you, but do you end up being positive even if that doesn't happen? Because I could see situations where you act as a cloud provider, a CDN effectively, and suddenly their caching costs, they don't have to serve all this from origin. Now it's suddenly saves them money instead of costing them money.
Yeah, you can look at, you can look at budget items and say, okay, how could we fund this? So we could save money over here, or we wouldn't need that anymore, or certainly that varies. And then there's also the opportunities that you can open up as well. We always say security should be a business enabler, and sometimes it's not always easy. We have a reputation of running around of being kind of harbingers of doom, and reality is that we want to help the company safely enter new markets. We want to help the company quickly and efficiently launch new products. We want to help the company safely acquire new companies. These are all pretty strategic outcomes for the business, right? And that's very much those are all kind of potentially strategies that run right to the top of a company.
So I've run a lot of my very good friends are SEOs or marketers or whatever, and I keep thinking there's something really cool that you could do with your product that would be like, you have these sort of old legacy websites that are out there that are really just brochure websites. They don't need to be anything more complicated than that. It's really just old blogs and stuff. And the content's great. It's just in the wrong place. And trying to port them over somehow would just be just a hot mess. It would just not work very well. But you could do application pooling and just say, hey, this lives on this new URL now, and now it's integrated in your app. And all you have to do is create a link to it somewhere, which you could do again as another, modification to the outbound request. And all of a sudden, you didn't have to touch anything. The servers stay up. Everything's exactly the same. You might change the Google Analytics key or something, maybe. I don't know, but that's about it.
And that can be pretty straightforward. So totally. Take oldportal.com and turn it into new portal / old portal. At a technical level. I mean, I think that's what you're describing architecturally, and that's pretty easily done. Yeah, I remember back when FI was first getting off the ground with their WAF product, I was asking him, can you do this? And like, no, why would you ever want to? And I'm like, no, this is so cool, you could do this. I'm really glad that they eventually built it. Oh, you definitely can.
That's amazing. I think there's a lot of value there. So if you mentioned nation states and a bunch of other crazy hacking and stuff. Can you give us some... does any stories kind of stand out that if they hadn't had this, it really would have been a kind of catastrophic situation?
Yeah, I saw you often. I think the best cases of that, you manage to intervene early, and you have a fair idea what would have happened next, but it actually didn't happen. So I'll give you an example. So this was last month, and there's an organization we work with, large financial services company, and they have actually, ironically, this was a brochure site, like what you're talking about. It didn't really do very much, but you have.
We're talking about Sony here.
Not Sony.
Do I have to edit this, Robert? Come on, give me a break.
Well, that's how Sony got hacked. It was a old forum that they'd sort of forgotten that they owned.
Right. Well, the thing with old, with brochure sites is that they're really, really good for spear phishing, because you can say, okay, it's some old site, but the organization themselves, their own staff, trust that website and they know that they own it. So if you send an email to the CMO and you say, hey boss, we've got this new copy going live, can you please just okay it for me? Just go take a quick look, and it's yourlegitimatedomain.com / some super evil content which is going to take over your machine. And the CMO goes, yeah, I'll go take a look. And every time someone sends you an email, you kind of quickly glance at the host name. Is that one of ours? Okay, all right, I trust it. I'm not getting phished here. Giving everyone the benefit of the doubt. Hopefully everyone's pretty vigilant. But it's a trusted domain. You see it and it is one of yours. And so you can go to a site that's either had malware embedded in it, or it's got an open redirect to evil site. And you can take control of people's machines, even through a system where you'd say, well, it doesn't contain any critical business information, it's just brochureware. But there's still quite a lot of, and also the other thing is that those sites will often sit on a machine which has access to other systems as well. So if you can take root control of the machine, for example, then an old unpatched system that enables you to actually get control of it, you can use that as a jump off point to go and do other things, which are really undesirable.
That's one of my specialties.
So that, no doubt, I'm preaching to the choir here. You know all about this. Okay, but so this example that I saw. Actually, I'll talk about an SAP system, and so this is no fault of SAP. This was custom code, and SAP tends to be really, really heavily customized. And most of the, well, I think a lot of the security problems that arise in SAP are not anything to do with the vendor, but it's what people have built and done with it in some sort of customized way. And so one site, it had an open redirect, and an open redirect. So what this means for any non-technical listeners is you can force the site to redirect a user to anywhere you like. So you could send somebody a link and say, hey, click on this thing, and it sends you to, and it's mytrustedSAPsite.com/send me off to some evil site without me noticing. And that link, you can put it in an email and send it to somebody. So we saw, as soon as the customer brought us on, we jumped in path, we started scanning. They didn't have any pen test results, but we could have a bit of a look with vulnerability scanners, and we saw this open redirect. We went through change control, put a shield in place, stopped that from working. And then last month we saw an attacker from Brazil tried a couple of times to get that very attack working. And it's kind of spooky because we saw what they're doing. We saw after the fact, we blocked all this stuff, right? So we're not, we weren't just sitting there watching the logs scrolling in real time, but we saw it afterwards by analyzing what happened. And they had tried from 3 or 4 different IPs, all in Brazil, all on different networks. And one of those networks we could actually see from the IP reputation is just a big spam cannon, and it's a phishing operation. And they're out scanning the internet looking for open redirects, and they were sure this website had an open redirect. They were trying pretty hard to exploit it, and we kept on blocking them. So eventually they moved on. But what they were trying to do there is to figure out how to get this working so that they could then launch a phishing campaign on this company's customers. This was their invoicing and online ordering portal. So the two things that you do then are crack all the accounts and download everybody's invoices, contact all their accounts payables departments and go, hey, Bob, it's Bill here from your supplier. New bank details, please confirm payment this month needs to go this way. And you can divert payments into a bank account of your choosing and offshore all the money. And then the other thing that you can do is order a ton of product and have it sent to dead drop addresses and steal the product. So we could see that this organization, this hacker organization, is set up to do exactly that. And that is what they were attempting to do. But you have to extrapolate forward and say, well, we saw these things getting blocked. We can see what this organization does and what they're capable of. I think they were going to do that to you, but they didn't. So it's usually kind of the case with what we're, I suppose the place in the chain that we are, that we tend to stop things that then don't evolve into that. So there's a little bit of speculation required there.
Not much.
But it's pretty easy to see where that was headed, right?
Yeah.
That kind of thing is just happening all the time. And this is why, again, I love my son too, prepare early and bad things don't happen. It is much, much better if you find all the vulnerabilities that you can, mitigate them all, and so that you're in blocking mode, so that basically you're less concerned about suddenly having to stand up an emergency incident response and going, hey, we've just been hacked. Because if you can see it, you stopped it. And any technique that anyone knows that could possibly hurt you has been mitigated. So you should be sleeping easier and bad things should not happen. But you get it, if you're in sitting there with kind of, at a technical level in alerting only mode, then you have to read all the alerts and you go, did this hurt me? Did I just get hacked? You have to read them all and figure out what happened. But if you're really properly blocking stuff, you don't. You blocked it. You can put it all in a pretty graph and figure out whether it came from APT 28 or just some organized crime group or whatever, but ultimately you blocked it. You kind of don't care too much.
So what kind of traction are you getting? Can you talk about your types of clients that are using you and how many clients you have,
Sure.
that kind of thing? Like, how are you guys doing?
Well, we talked earlier about, does it make sense for organizations to be in security? And I mentioned the very, very large organizations. I think it does for them. So we're kind of, think, let's say, outside the Fortune 50 on down. mid-size organisations. And if you think in smaller nations like Australia and certainly New Zealand, a lot of our customer base are, just by nature of those countries, they're somewhat smaller organisations than you get in the US. So we tend to be kind of mid-market US and higher end in Australia, New Zealand, and we have some European and UK customers as well. But yeah, I mean, we're 10 years into it and we're still managing to grow fast, which is awesome. And it's pretty exciting times. I mean, we're still finding ourselves amazingly in this kind of in this niche, which just seems to be becoming more relevant.
Where do you see the industry going? I mean, is there going to be another big innovation in WAF designs, or where's things going?
I think the innovations in WAF designs, the really important innovations, I think, happened in the mid-2000s. They became programmable. So you can do what you want with them, and you can solve any problem, but it's up to you. So from that point on, it's been, okay, well, we've got the tools. That was the easy bit. Now, how do we get through the change control? How do we do this safely? How do we influence the organizations? How do we fund this? How does it, all of those kinds of
tooling around it.
Right. And it's the
business of building the shields and talking about them and
the organizational psychology. So I think the innovations to me are, I think that a lot of the really exciting innovations are actually in services where you're getting business kind of processes, quite major business functions, which can really neatly be outsourced in an efficient way that interfaces nicely. And you're just getting more and more maturity built up in these kind of specialist functions that you can plug in. I do see that the industry is headed much more towards kind of test-driven, results-oriented. So, security for so long, it's felt really theoretical, and people love to think about the sort of the theoretical impacts of one technical decision or another. But if you step right back from it and go, okay, but how do I look to an attacker? And you can see a ton of vulnerabilities, then, well, let's start there. Okay. You've got a lot of exploitable vulnerabilities. Let's see them cut in half in 12 months time, or let's see them, maybe we can get them 80% down in 12 months time, but it's going to require a lot of work in the organization. And it means people have to agree that security is important. People have to take a little bit of time to understand what you're asking, and you're really just asking permission, but you need permission to make a change. And so creating that kind of efficiency, I think, is one area where a lot of innovation is happening. For example, we talked about the being able to just kind of cut and paste ready-made compliance documentation. Those types of things really just smooth the process out. And I think a lot of organizations are also going to find that cyber insurance, becomes ever more of a driver. So insurance companies are seeing that even some organizations, even at any price, are really not insurable because they're a claim waiting to happen. And so the insurance companies, the challenge for them is in understanding whether or not that's a risk that they should take on, and then at what price. And then for organizations to go, wow, okay, so we're actually uninsurable. What do we have to do then? And taking practical steps, sometimes for an organization which might have been caught up in how organizations work, large ones, you can have, there are politics can get in the way, and budgets can get in the way, and priorities can get in the way. This is why I think, the really big changes are being driven from the board level down. And, as engineers, we kind of don't tend to think of major changes happening that way, but really as business people, that's absolutely how it happens. Mm-hmm. And insurance companies very much are relevant at board level, because you've got, directly boards of directors have to handle risk. And so insurers increasingly, I think, are going to start calling the shots, and it's going to be you're insurable and you're not. And that makes a really, really big difference now it could flow on to your cost of capital as an organization, how you're going to fund your operations if you haven't got proper insurances in place. So I do think that's another major change that's happening as well.
I agree. In fact, I think insurance will end up driving a lot of companies out of business because you need insurance, because your clients demand that you have cyber insurance. Otherwise, they're not going to do business with you. And you're not going to be able to get it because you got hacked last week and they don't want to insure that twice. And so it's a timer. You probably have a year to stay in business, and then after that, you're going to go out of business because you're not going to get insurance twice. So I think insurance is going to be one of those things where you have it and you don't get to use it.
Yeah. Yeah. And it's a little bit like, investing in security is itself a lot like insurance. And it's one of those things, if you don't buy insurance for your house and your house doesn't burn down, then great, good decision, but if it does, that's a problem. And it's a bit the same with security as well. I mean, you could underinvest in security for a year or two, maybe 3. But then when you get breached and you have to apologize to the markets and the CISO gets fired and you're in front of a committee hearing about what happened, well, we saved some money.
I think it's kind of like your house burning down if you're like a fire juggler,
right?
Well, they know that you weren't at fault in the sense you were trying to burn your house down, but are you going to get insurance twice? What about the third time? No, I think they are going to know you're a fire juggler. And no, not that one.
Yeah. Well, not that one, or not that entire population of fire jugglers.
Yeah, exactly.
Because there's a lot.
Exactly. All right. So, well, that was very interesting. How do people find out about you and the product and get in touch with you?
Hit us up on redshield.co, redshield.co, and or on LinkedIn. And we're really, really easy to get in touch with. So call us if it's an emergency. Call us if it isn't.
And call me maybe. Well, that's great. Any last things you want to tell the audience? You got a personal blog or anything you want to direct them to?
Everything I think is through LinkedIn and through redshield.co. Okay. And yeah, we're definitely looking forward to connecting with some of the viewers of this show.
Oh, great. Well, thanks for coming all the way from New Zealand. I mean, that's a hell of a drive.
Yeah, it is.
The commute, it just keeps going.
No, it's fun. It's fun. I'm here often. So yeah.
All right.
Thanks, Robert.
Yeah, thanks for having me.
All right.